Okay, here's a short and sweet concept of division of polynomials. No, you're not losing your eyesight. It's my camera focus, as you can see, not that high tech yet, but I'm sure I'll get there one day. So, um, so the book only have about 5 problems, I believe. Four problems here. Yep. And I'm gonna get into the example of 4. So I'll jump right in. So what will come in handy is your rules of exponent for division. Your rules of exponent when dividing same base exponentials, right? So remember, we said if we have the same base, x to the n over x to the m is the same as saying x to the n minus m. So example, if we have x to the 5th power over x squared is the same as saying x to the 5th minus 2, which is x cubed. And we proved how that concept came about, how this formula came about in my videos on rules of exponent. So let's jump right in. So here's an example. Here it's asked to divide 8x squared y minus 4xy plus 12x over the factor negative 2xy. Pay attention that I said the factor. All right. Now, as a rule, considering that this is just one factor, we know that it applies to all the terms in the denominator. So for example, if we had 4 minus 12 over 6, we could say it's the same as saying 4 over 6 minus 12 over 6, which of course it's, we can reduce these two. I'll just do it. They have a common factor of 2, so this is 2/3. And this is actually a whole number because it's an improper fraction with no remainder, 6. You can find one factor of 6 in 12, and you will be remaining factor of 2, so that'll be 2 over 1. Or, which we'll have to, this is like a reoccurring demon. I just noticed we'll have to find an LCM all over again. Or simple, because I forgot my own principle, because they have the same denominator, you can combine the like terms. So this would be negative 8 over 6. Now we can reduce, and this will give us a factor of 4 over 3, negative 4 over 3, which is the same as saying negative 1 and 1/3 if we converted it into a mix. So in this case, we have two constants, they're like terms. We can evaluate this expression here with a common denominator. So really the point that I really started to make is not how to evaluate fractions. It's actually to say that whenever you have a group of terms shared by a denominator, one denominator is the same as those group of terms split into separate terms with the same denominator. So in this case, why that concept comes in handy is that if we look at our numerator, we see it's a group of terms that are adding and subtracting simultaneously. However, there are no like terms. Remember, the definition of like terms means that they must have the same variable factor. In this case, they have x and y and x here. And however, it must be the same variable factor and exponent simultaneously. And if you look at this expression on this numerator, there are no like terms to combine because they do not have the same variable factor and power simultaneously. So as the concept with 6 over, 6 as the divisor for 4 minus 12, where we can make them two terms, we can apply the same concept here. So this can be rewritten, which I advise, as 8x squared y over negative 2xy minus 4xy over negative 2xy plus 12x over negative 2xy. All right. So in this case, we do not have to find any LCM. The question is asking you to divide. to divide. So this is how we're going to operate on this. We're going to use our laws of exponents with the same base. You subtract powers. So here we go. The constants speak for itself. So we can see that the common factor between 2 and 8, negative 2 and 8 will be negative 4. We have two similar bases, x's, with the power of 2 and here the power of 1. If we subtract 2 from 1, we have 1 still. And then we see we have the power of 1 minus the power of 1. Remember the rules of sign says 1 minus 1 is 0. Anything to the 0 power is 1. So this is 1. That's where the concept of cancellation comes in, because writing 1 is redundant. Just saying we have one factor of something. So here we go, bam. So that cancels out, or it's really 1, right? Y divide y, 1. So we're just left for this term. For this first term, 8x squared y divided by negative 2xy is, we have a remaining factor of negative 4x. Here now we have the other term. Here we have, let's look at our rules of sign when working with factors. Like signs gives you a positive. Let's work on that first. And we have 4 divide 2, which is 2. And also we see that they have, the bases are alike with the same power. So that cancels, right? And then we move on to our next term. Negative divide a positive is a negative. When we're working with factors with unlike signs, it yields a negative. Here we have the factor of 2 to divide 12, which will give us 6. X's cancel, and we'll have a remaining factor in the denominator of y. So our new expression from that division is negative 4x plus 2 minus 6 over y, as we can see in the example of our text. So what I'll do, because we have so few examples, I'll just do the first one for you. That's in the book as a second example. So here we have 12x squared plus 6x over 3x, right? Remember that this divisor is common between the two terms in the numerator. 12x squared over 3x plus 6x over 3x. So when we look at the constant factor, or we can say the coefficient of each variable factor here, this is 4. And the difference between the power of 2 and the power of 1 is 1. So we're just left with 1x. Plus, these are positive, so it remains a positive. This is 2. And we see that the power of x divide x is 1, because we prove already 1 minus 1, x to the 0. X to the 0 is 1. To write 2 times 1 is the same as 2. It's just being redundant. So our solution here should be 4x plus 2. Let's see if we are correct. Yes, I did check the answer. Boom, 4x plus 2. Okay, so what happens if our divisor is not just one term? What happens if our divisor is 2 terms? So for example, what happens if we have 3x squared minus 10x minus 8 over x minus 4? Ha! So this gets a little tricky now. Now we do not have one factor, we have 2 terms. So if we were to separate this will not, look at that. Oh my goodness, 10x. Ooh, what are we canceling? What are we canceling? Nope, nope, nope. So here is where our next type of division of polynomial comes in, the real McCoy, where we have to apply the concept of long division to find the quotient of a polynomial where the divisor is more than one term. And that will be in our next video.